Hi everyone. So today's problem of the day is minimum total distance traveled. So what is given in the problem is like there are some robots and factories on the x-axis, and you are given an integer array robot where robot I is the position of the ith robot. You are also given a 2D integer array factory where factory j equals to this is a 2D integer where first index is position, it is denoting position, the second index is denoting limit. Indicate that position j is the position of the jth factory and the jth factory can repair at most limit j robot. The position of each robot are unique. The position of each factory are also unique. Note that a robot can be in the same position as a factory initially. Although robots are initially broken, they've been moving in one direction. The direction could be negative or the positive direction of the x-axis. Direction is not given. Direction we can take by ourselves. And when a robot reaches a factory that did not reach its limit, the factory repair the robot and it stops moving. At any moment, you can set the initial direction of moving for some robot. Your target is to minimize the total distance traveled by all the robot. Return the minimum total distance traveled by all the robots. The test cases are generated such that all the robots can be repaired. And what is the note? All robots move at the same speed. If two robots move in the same direction, they will never collide. If two robots move in opposite direction and they meet at some point, they do not collide, they cross each other. If a robot passes by a factory that reaches its limits, it crosses it as it does not exist. If the robot moves from a position X to a position Y, the distance it moved is Y minus X. So basically इस problem में क्या दिया है, like we have XY plane and in the X axis there is nothing given for the y-axis, only x-axis is there. So in the x-axis, what it is given like at some place there will be robots. Suppose R1, here we have R2, and here suppose there is factory 1, factory 2. So there are a number of factories and the number of robots. And what is given is like this robot, like usually you see robot problem. So robot case, robot will collide, destroy something kind like this problem you have solved. But in this case, there are few conditions like R1 and R2 can be moved in any direction. We just need to minimize the total distance traveled by all the robots. And second condition is they can move in any direction. And the second condition is like if they will collide R1 and R2, if suppose R1 and R2 will collide, so they will not destroy, they will move continuously in their direction. R1 and R2 will not have any effect of each other. And one more thing is given in this question is like F1 factory is there, suppose, and suppose this R1 is moving in this direction, it will move until there will be some factory whose limit is still remaining with that factory. Suppose कि अगर ये जो factory limit है that is 2. If it is limited to 2, then maximum 2 robots can use this factory and they can stop moving. अगर ये R1 is moving in this direction and if this factory limit is suppose 2, so it can use this limit and this limit will become 1 and it can use and it can stop at this position. But if you will talk about this robot, if this robot is moving in suppose some in this direction, suppose this due to some r dash robots, this is also moving in this direction, and because of that this capacity becomes 0 for some reasons you can assume. And we have one factory whose limit is 0 now, and there is F2 factory, and for this F2 factory also there is because of some other robot in this direction, this limit is also 0. So what this R2 robot will do, it will move either in this direction or in this direction, and it will move until it will get the factory with some limit. Remaining limit should be greater than 0. Then only this, with the help of that limit, this robot can stop because it is initially broken. And the factory what the factory is doing, factory is basically repairing the robot and it stop moving. So basically with the help of limit is basically the value कि जिससे कितने robot अपन repair कर सकते हैं, and we ultimately need to repair all the robot uh, present in the robot array. डायरेक्शन अपने इज डिपेंडिंग ऑन अस, पर मतलब कोई भी डायरेक्शन में रोबोट को मूव कर सकते हैं, लेफ्ट और राइट. बट इफ द लिमिट ऑफ F1 factory is like suppose X, then we can't repair more than X robot with that factory. We need to move to other factory to repair other robot. And in this case, we need to minimize the total minimum total distance traveled by the robot. If robot is present at this direction, suppose it is at 2 and factory is at 4. So robot needs to move till 4 to repair itself. So it will move how much distance to 4 minus 2, that is 2 distance. Like that, all the robot will the distance it will take to reach till factories, their corresponding factories. That the distance we will get, and we need to sum all the distances and we need to find the minimum total distance. So इसको अपन कैसे करेंगे? अपन सबसे पहले example we can check it with the help of example. So suppose in this example we have given robot, one robot is at -1 position and the other robot is at 1 position. Then we have one factory is at -2 position and its limit is 1, and one factory is at 2 position and this limit is also 1. So basically, we can move. We have this robot and this robot. We have basically two robots. So there are two options. This robot can move to this factory, and this robot can move to this factory also. But in our case, we need to find a minimum distance. And to find the minimum distance, we need to traverse the nearest factory we need to traverse. So for this robot, we will traverse to this factory, and since it has limit which is greater than 0. So if this robot will move to this position, that is -1 minus of -2, that is 1. It will move one distance. Then if it will move at this position, it will find this limit is greater than 0. So it will consume that limit and this robot will get repaired. So in this case, the distance for this robot is 1. And if we will see about this robot, since it can move to this side also, but it can't move to this side because this limit is already 0. So it will move to this side. And if it move to this side, then this distance is 1. So if this distance is also 1 and this distance is also 1, if we will find a total distance will be 1 plus 1. So it will be 2. So we can return 2 in our answer. So if you will see at the problem, for this robot, there are two conditions. It can move to this robot, it can move to this factory, it can move to this factory also. And if there are some other factory also, like there is a big x-axis and there are so many other factories also. So this robot has option to move to other factories also. So it is a kind of recursion. You can see it as a recursion because in recursion, any robot can move to any factory. So there are so many like repetitive case in our case, and we need to do a recursion because any robot can move to any factory. We will try to find all the possible cases, and we need to while finding all the possible cases, we will try to find the minimum possible distance, minimum possible total distance. अगर अपन एक और एग्जांपल देखते हैं for the better clarity, तो अपने पास रोबोट है 0, 4 and 6 position. These are the robot, and 2 and 6 these are the factory. Now if we will see, this factory has limit 2 and this factory also has limit 2. Now if we will see for this robot has option to go to this factory also and this factory also. Since this is like the minimum distance, so it will go to this side, and this left side there is no factory, so it will surely not go to that side. So if it will try to go to that side, then this distance is 2. So for this distance, for this robot, the distance is 2. We will try to find for this. So now this robot has this robot has two options. This factory it can go and it can go to this factory also. So if it will go to this factory, there is a distance of 2. and if it will go to this factory, there is also the distance is 2, so it can go to any any factory it can go. So if we will go with this factory, because the remaining limit is 1 for this factory, because 1 is already consumed by this robot. So for this robot is also we got minimum distance plus 2. For this robot, it is at the same position. For the minimum distance for this robot will be 0. So we will find a total distance. Total distance will be 2 plus 2 plus 2 for this robot plus 0. So it will be 4. So we got 4 as our answer. So in this case, one thing also we need to note that we need to since we are finding the nearest factory for every robot, so we need to do with the help of sorting. We need to sort all the robot, because after sorting only we will try to find the factory which is nearest to it, because this robot we will try to find for this factory, because if we will sort it, then we will get ki मतलब जो minimum वाला है that we will automatically get. So we need to sort the robot and the factory. Then if I will come to the constraint. Constraint is like robot dot length and factory dot length will be less than equals to 100. Factory j dot length equals to 2, because at 0th index it will be position, at 1 index it will be limit of the factory, and this position will be from minus 10 to the power 9 to 10 to the power 9, and this limit is equals to 0 to robot dot length. And the input will be generated such that it is always possible to repair every robot. So there will not be negative case ki we are not able to repair any robot, because all the factory available in our case has the limit 0. It is not possible. So we don't need to think about this edge case that we don't have any factory, because it is given in the note in the constraint only that it is possible to repair all the robots. So if we will coming to the solution, we will try to do it with the help of recursion. So recursion, what we have done, we have declared n length, which is the size of the robot, and m, which is the size of the factory. As we discussed, we will sort both the robot and the factory, because we need to find the nearest factory for all the robots. Then don't think about this DP as of now. We will just try to do the recursion, then we'll come to the DP, how we are using DP. We added the DP here. So in this function, we will call this function, this is the robot index, this is the factory index, this is the robot length, this is the factory length, and robot factory we will pass. Then this is the function. Then if I equals to 0, I equals to n, sorry, I equals to n, that means we reach the end of the robot. That means all the robot we have already, we are done with traversing all the robot. So we can return 0. And if we didn't get this, and then that means if we reach the end of the robot, we can simply return 0 in this case. And if we are coming at this line, that means we still have some robot to traverse. And we got j equals to m. J equals to m means all the factories are done. We don't have remaining factories. We can repair our robot with that. So in this case, we will return the maximum value. In our case, we have written 1e15 in this case, because generally we will do 1e9 to denote the maximum value, but here we are using long, so we are using this 10 to the power 15. Then what we are doing in this case, this is the case where we are suppose we are not using that particular factory. I is the robot index and j is for the factory, jth factory. Suppose we are not using jth factory, so what we can do is like we can store in our result that we are, in this case, we are not using a jth factory. So directly it will do, it will call this solve function with the ith robot and j plus 1 factory. We jump to the j plus 1 position, and m factory and robot will be same only. Then this position and limit, this is the position and limit for the jth factory. Then this is the cost. We will try to find the cost using this loop. We have declared a for loop. This is starting from the k equals to 0 to k less than limit, because this we are doing for the this basically we are doing for the jth factory. So if because like k equals to 0 to k less than limit, and I plus k should be less than n, because I is the robot that ith robot, and plus k is the limit. If it will go if it if it will go beyond the robot, we need to like return from that. So we need to traverse only till I plus k less than n and k plus plus. So what we will do is like we will use this I robot I plus k. That means this I plus kth robot minus POS. So this is showing like we are using I plus k robot we are using for this jth factory. This robot I plus k is consumed by the jth factory. So its cost will be robot I plus k minus POS position of that factory, and the result will be minimum of result, because we need to find the minimum value. So we will use minimum of result comma cost will be this cost only, and we will move to the I plus k plus 1, because this is our I plus k robot. So we will move to the next robot will be I plus k plus 1, factory will be j plus 1, and m robot factory and dp will be same only. And this is the like recursion, and we will return this result. And if we have to use dp, to dp we will be using like we need to, how we will be find key which dp we need to use, like 1d dp we need to use or 2d dp we need to use. This we will find with the help key how many variables are changing in this function. If you will see this function is this variable is changing and this variable is changing, that means robot index and factory index is changing. So two variable are changing, two parameters are changing basically. So we will use 2D DP vector. So we have used 2D DP vector. One is for the robot index and one is for the factory index. And we will initialize it with the -1. -1 is denoting that we have not yet traversed to that index. Now this DP of ij, we will check if it is not equals to -1. That means we already got DP of ij value. That means ith robot is using jth factory. If we already got this is not equals to -1, that means we already got this value. So we can simply return it. And if we didn't get it yet, we will try to find all the possible cases using the recursion, and at the end we will store this dpij using this res integer. And it is we are storing because if in future we want this dp of ij, then we can directly with the help of this dp vector we can directly return it at this line only. So yeah, that this is the problem. And if we will check for the space complexity, the space complexity will be n into m, because we have used this vector. And this and in space complexity there will be big of m. Big of m is the recursive stack. But since we will try to, this is big of m, this will be like less than this n into m. So basically it will be equals to big of n plus n into m only, space complexity. If we will talk about the time complexity, so time complexity, what will be the time complexity? Time complexity will be n into m, because we are using this robot and factory, and we are using this for loop also. For for loop, it is going till limit. So limit, we have already seen in the constraint that limit can go till n. Robot dot length, limit can be equals to robot dot length, so it will be n extra. The time complexity will be n square into n. In space complexity is n into n. Yeah, thank you.